start our recording here. I think we're good. Just change this. In my mind, November's over already, but I'm like, oh yeah, it's basically December. Not quite. Yeah. Oh yeah, it'd be great. Not quite the case. November 5th. Okay, so you got two things, right? I'd say, well, they're the same, basically, right? So if you go ahead and just kind of read the questions later on, you'll find that the questions are basically the same, just about different stuff, right? And so next day, right, we have our review class. And so we're gonna go through the practice test together. For a little bit of a twist this time, I want you to do the practice test before class. And I know that's short notice, but look at how short it is. Don't worry, it's a lot of work. It's still a practice test after all, okay? But I want you to do the practice test for just a completion mark. So it doesn't have to be right or anything. Just do it, show me that you did it, and then you get a completion mark, and it's basically like getting an assignment with 100%. Okay? So pretty good deal. You don't have to do it right or anything, just all I want is for you to try to do it. Okay? Okay. So do the practice test for class on Wednesday when we'll go through it together. Okay. And then assignment 4 isn't due until the test day, right, which is right after we get back from our long weekend. But because you'll have time to ask me questions beforehand, I will be in Ottawa, obviously, so it'll have to be by text unless you do it before I leave on Thursday. Okay? But then I'm not back until Tuesday. So let's write some of this down. Ooh. So do the practice test for class on Wednesday. Show me your work for 1 completion mark. Counting as an assignment. Only 4.1 and 5.1. But basically the practice test and assignment 4 is all it's doing. So it's like a little check-in point because we'll have finished hypothesis testing with both a formal hypothesis test and a confidence interval. So I just want to check in with you guys, make sure that we're all on the same page, right? And then we can keep going because then, like I said, after that, everything's kind of the same procedure, right? Different types of questions. Yes. Yeah, so then after that, the final will cover everything after, as well as everything we've done before. But obviously more emphasis on what we do after test 2, right? Okay, so make sure you do the practice test. Easiest 100% assignment that you could do. It blows my mind when people don't do it. I've done it a couple of times before and people just don't do it. It's weird. So make sure you grab that if you're coming in now, or if I caught you. And then assignment 4 is due on the test day, right? So assignment 4 due November 14th, right? So if you have questions that you need to ask in person about assignment 4, or probably more likely the test, they'll be the same, right? In-person questions have to be done before Thursday, because I fly out Thursday night or Friday morning. I can't remember. Doesn't matter. Should probably look that up. So any in-person questions? So big concepts that you need explained, you have to come see me before Thursday night. Need to be asked before Thursday night. That means you have to start looking at this stuff before the weekend. That's kind of rude, I know, but kind of uses up your weekend too. Of course, you can always ask questions. You can always text or email if you have questions. Who knows? Who knows with those labs? Probably not until that week at midnight or something. I'll give you guys a heads up, but I'm not too worried about the labs, so you shouldn't be either. You catch my drift. Okay, so let's see. Does anyone need to borrow a table? Okay. So last day, right? Oh, and I have a bunch of assignments and stuff to hand back. So that's all I've got for loaners. So if you have stuff that you need handed back, it's here. You can grab it after class. Okay. Any questions about assignment 4 or the practice test? Right, so we'll go through the practice test together on Wednesday. Then you'll be all prepared. Okay. Let's do a little bit of review. Right. We talked about hypothesis testing in general, right? So where we have some sample information, and then we have some theory or hypothesis that we want to test, right? So either prove or disprove or something like that. Okay. And we started that example on dissolved oxygen, right? But let's just write out. So for hypothesis testing, hypothesis, or I'll say / significance testing, because it can also be called significance testing. We have 2 options, right? We could do a formal hypothesis test. Right, and I said this is kind of the traditional way that we've always been doing things, right? A formal hypothesis test. And we looked at, well, what does that involve? It means stating our null and alternative hypothesis, right? And then doing the test where we calculate our t, right, to see how extreme our observation was. And then we have to find our p-value, right, which is the probability of being more extreme or as extreme or more extreme than what we saw. Right? And then we draw our conclusion. We talked about those generic conclusions. That's a lot of stuff that I can't really write it all down again. That was a whole lecture, but I will put down the steps here. Right, so step 1 is to state the null and alternative hypothesis. State null and alternative hypotheses. Step 2, I call it do the test. It's whatever calculation follows your null and alternative hypothesis on your formula sheet, right? So what you'll find is that for each type of question, you'll be in a different section of your formula sheet, right? So we're in the 5.1 section, right? And so we only have one test, and that's the t-test, right? So calculate a t. And then we use that t that we calculated, right, to find the p-value. Find the p-value. And the p-value is going to be the probability of seeing something as extreme or more extreme than what you saw, right? Meaning it's always going to be an area in the tail, which we know how to find using the t-table, right? So when we've calculated a t, we have to find the degrees of freedom, and then we can go down to the bottom. Once we've found which numbers bracket our calculated t, we go down to the bottom to find our one or our two-sided p-value, depending on which situation we have. Right, the one or the two-sided depends on our alternative hypothesis. Right, if you have a not equal to in your alternative hypothesis, then you have a two-sided test. If you have a less than or a greater than, right, you only care about one of the extremes, then you have a one-sided test. Right. That's a lot of stuff. So our fourth one is our conclusion. And we talked about our conclusion. We wrote up generic conclusions, right? So what we say is that if the p-value, right, is less than the alpha level, right, the alpha level, I either give it to you or we use a default of 0.05, right? So I'll just do our conclusion here in general. If our p-value is less than our alpha level, okay, which has a default alpha is 0.05, right? So if I don't give it to you, or if you're out in the field testing stuff, then you just use 0.05. Or I might say use an alpha level of 0.01 or something like that. Okay. So if our p-value is less than our alpha level, right, meaning that it's the area in the tail is less than 0.05, right, so you're far away from the hypothesized mean, then we have enough evidence to reject H naught in favor of HA. If our p-value is not less than 0.05, or the alpha level, okay, then we don't have enough evidence to reject H naught, right? So you either have enough evidence to reject H naught or you don't have enough evidence to reject H naught. There's no other options, right? And so we wrote out those generic conclusions, and then you're going to state your conclusion in terms of the question. So today, we're going to finish up that hypothesis testing example, and then I did kind of start making a list here. and we'll get to hypothesis testing with confidence intervals. So we can use confidence intervals to test the hypothesis. And that's what I'll show you how to do today. So talking about what is a confidence interval, right? How do we use it to test the hypothesis? Let me just see where we got to last day. Yeah, I'm just seeing. So I'm just gonna steal this blurb again, and I'll steal the last text that we wrote as well. So from last day, and I'll steal, so, right? Just as a quick refresher, right? We wanted to know, right, because we're told that a dissolved oxygen level less than 5, right, is bad news bears. So we want to test our water and figure out what the dissolved oxygen level, calculate the mean dissolved oxygen level, and make sure that it's not less than 5, right, because that's bad. Okay. So is there evidence that the aquatic life is at risk at the alpha equals 0.05 level? Right, so what we had to do, right, is we're given some sample information, right? We have a sample size of 15. We don't need to show the data, but it's there. Okay. We have a sample size of 15, and then we've calculated the mean to be 4.771 and the standard deviation to be 0.9396. Right? So that's your sample information. You want to test if a mean of 4.771 is significantly less than 5, right? We want to know if it's significantly below 5. We know 4.771 is less than 5, right? But there's some wiggle room in there where it's not significantly less than 5, right? It has to move far enough down into the tail to be considered significantly less than 5. And that's the whole idea. Okay. So we set up our hypothesis, right? And so your null hypothesis is that mu is 5. Right? So your null hypothesis always has an equal sign. And we want to know, how does our sample information compare to 5? Right? And so that's how you're going to pick this number here. It's not anything from your sample, it's whatever you want to compare your sample to. We want to know if mu is actually less than 5. Right? So what we do is we do all our testing assuming that mu is 5. And then if we find that x bar is 4.771 is way down in the tail from 5, right? Then we have evidence to say that mu might be less than 5. Because I'm only concerned with one extreme, right? I have a one-sided test, which means I need to find a one-sided p-value later on. Okay. Then we were back to kind of normal, where we're starting to feel comfortable, right? Calculating our t. Our t tells us how far 4.771 is from 5, right? Turns out it's not that far, right? T needs 3 decimal places, so we rounded to -0.944. So we have a calculated t of -0.944. Then I'll steal this. Oops. So that we can pick up here. So then we had to find our p-value, right? We find our p-value using the table C or the t-table. Okay. And so what I want you to do when you're doing this is just explain to me what you're doing. Okay. So using the t-table with 14 degrees of freedom, right? May as well throw that in there to show me how you found it, right? The whole goal is to show off how much you know, right? And so using the t-table with 14 degrees of freedom, we find that t of negative 0.944, if we drop the negative, is between 0.868 and 1.076, right? So working on that 14 degrees of freedom line, we find that our calculated t is between these two values. Okay. So our one-sided p, right? Because we said we have a one-sided test, we're only concerned with one of the extremes. Right? We don't care if the dissolved oxygen level is more than 5, right? That seems to be fine, right? We only care if it's less than 5. So here you have your one-sided p is between 0.15 and 0.20. Okay. So now, oh, any questions about that before we keep going on it? Okay. So now this is our kind of new stuff. Okay. So our one-sided p-value is between 0.15 and 0.20, right? Both of these are above 0.05, right? We were told to use an alpha level of 0.05, and so these are above 0.05, which we suspected that we wouldn't be rejecting the null hypothesis, right? Because this isn't far into the tail, right? It's pretty close to the mean. Right. So now we apply that generic blurb to this question. Right. We have to compare our p-value to the alpha level. Right. Is it less than the alpha level, or I say not less than the alpha level, just to keep the same wording. Right. Less than or not less than. Okay. And so because it's not less than the alpha level of 0.05, right, we don't have enough evidence to reject H naught. Because our p-value has to be smaller than the alpha level to reject H naught. So our conclusion I'm always showing off what I have and what I know, right? So since our one-sided p, right, or our one-sided p-value, as we're calling it, is between 0.15 and 0.20. So since our one-sided p, or one-sided p-value, is between 0.15 and 0.20, then our alpha level of 0.05. Which means we do not have enough evidence to reject H naught. Okay. This is really the only way that you can write this sentence. So I don't want you to try to be a hero and make up your own sentence. It doesn't work that way. You'll no doubt say something that's not true, okay? So I know that seems kind of, I don't know what the word is, controlling, right? But you have to use that sentence that I gave you, Because otherwise, no doubt, whatever you say will be wrong. This is basically the only way that you could put it out there, okay? So it's not wrong to use that sentence. In fact, I need you to use those generic sentences that I gave you last day, right? Oh, it was in the question, but even if it wasn't in the question, the default is alpha 0.05. Okay. Yeah. Good. Okay. So, if we can't reject the null hypothesis, right? I guess I should have copied the null hypothesis. Let's see here. I'll just sneak it in kind of tiny here. So recall, it's tricky when we're working across days of notes. Probably not for you, you're all in the same place, but for me. Yeah. So our hypothesis, right, our null hypothesis was that mu is essentially 5, right? Our alternative hypothesis that we wanted to test, right, in this case, we didn't really want this to happen, right? So whatever we're testing goes in the alternative hypothesis, right? And then in our null hypothesis, we just have mu equals to whatever we want to test against. Okay. If we don't have enough evidence to reject H0, then what are we saying? H0 is the statement that mu is essentially 5, mu is 5. So we're saying that this sample mean of 4.771 came from a population where it's likely that the mean is 5, not less than 5. Okay. So the whole idea is that, so say the edge of this table is a mean of 5, right? Even if I'm standing here, you would probably still say that I'm standing by the table, even though I'm a little bit off, right? It's not until some point that you're like, oh, she's standing over there by the something else, right? Not the edge of the table, right? So that's where I want you to think moving further and further out into the tails, right? There's going to be some wiggle room in the middle where, yeah, the mean is probably 5, right? Okay. So in terms of the question, because that's what we had to, that was our whole goal of this, right? Our third part of our conclusion is in terms of the question. And so we say, therefore, and I don't know, I like to just regurgitate the question as an answer. Okay. So, is there evidence that the aquatic life is at risk? No, there is not. And that's fine. Okay. So, therefore, there is no evidence that the aquatic life is at risk.
Are you shorthand when we're doing the conclusion?
Oh yeah, therefore, for sure. Throw some dots in there instead. Why not? Okay. You just want to make sure that you're not missing anything. Yeah. Okay. You did it. You did your first hypothesis test. How's it feel? Pretty good? Feeling like you can prove some stuff? Great. So what we're working with, right, just to do a contrast to the rest of the types, right, we're talking about one sample mean. Then we'll talk about matched pairs, right, which is another type, but same idea, right? So you do a hypothesis test the same way all the way throughout these chapters, right? And then we'll compare two sample means, but the formula for T changes, but the whole concept stays the same. I'm counting this as part of the conclusion. So the conclusion has 3 parts. Let's see here. So you have to do your conclusion in terms of how does your p-value compare to the alpha level, right? Is it less than or not less than the alpha level? And then what does that mean for your null hypothesis? So you either have enough evidence to reject H naught or you don't have enough evidence to reject H naught. And then finally, in terms of the question. So your conclusion will be 3 marks, which is a lot, right? But that's the conclusion is the reason that we're doing all this, right? And so I need you to get it right. Okay. So 1 mark, 2 marks, 3 marks. Any other questions? Less. Okay. So first, so now let's talk about confidence intervals. A confidence intervals for hypothesis testing. Oh. Now's a good time to show you. If you're having a hard time keeping track of, because for now it's all these T's and P's and whatever's, right? So the p-value has to be less than the alpha level. Just right there, you have 2 things that we don't really associate with anything, right? But I've got my favorite of all time, and I was pretty proud of myself when I found this. I'll make it nice and big. If the p is low, then the null hypothesis must go. So I think it's really funny. It's really catchy, and so I really like it. But the number of times that I see, if the p is low, then the null hypothesis must go, scribbled on the pages of final exams, just to kind of remind yourself. Yeah, I like it. It's catchy, helpful. Okay. So before any of this starts making sense, just remember, right? If you have a small p-value, right, then you can reject the null hypothesis. Or just think of our man Snoop. Okay. Now we can do our confidence intervals. Oh, maybe I can just move it. Can. Neat. Yeah, this is probably my favorite one of all time. So, you've already built confidence intervals. We just haven't been calling them that. Okay? So a confidence interval is, if I asked you what 2 values, right, capture the central 90% or 95% of this population, right? Or what 2 means capture the central 90% of means or 95% of means, right? So we know how to do that because you've got your confidence level that you pick at the top, right? And then we use our we scroll down. We have been going down all the way to the Z star, right? To find that critical value, we're going to start calling it now. Okay. So we have been founding. We have calculated confidence intervals already. With questions like, what means capture the central 90% of means? Right. Let's use the same sample information. I have a different example, but it might be nice to just use the same sample information. 90%, sorry. There you go. So let's use the sample or the dissolved oxygen sample. Where X bar was, oh, I was thinking of must be morning, 4.771. S was what, 0.9396? I'll check. Yeah, nice. So if we want to know, right, what two values capture the central 90%, we've got some mu here that we don't actually know what it is, but we're going to find X bar lower and X bar upper that make this area 0.90. If the central area is 0.90, then the area in each of the tails, right, must be 0.05, right? So then this area is 0.05, and this area is 0.05. Right, because they have to add to 1. 0.9, we've got 0.1 left over, split it in 2, has to be even. So the whole idea before, right, was, okay, if we find that 4.771 is far enough into the tail, right, that it's past this region, right, or in this region, our alpha level of 0.05, then we can reject the null hypothesis. What a confidence interval says is that, okay, well, if you're 90% confident that this is the region, right, and your hypothesized mean falls in that interval, then you can't reject the null hypothesis, right? It's if this confidence interval is shifted off in either direction, right? That's the same as being pushed out into the tail. Okay? Won't really make sense. Okay. So what we've been doing is we've been finding the Z star, right? And then calculating X bar, right? So we have been finding Z star, right? using table C, then solving for x bar lower and x bar upper to find these bounds. Now, we're going to do the same thing, but we have just a shortcut calculation that we can use. Okay. So now, we will use x bar plus minus t star times s over root n. To find the upper and lower bounds. So slightly different, but the concept is the same, right? Two values that capture the central 90%. So notice that this doesn't require any mean, right? No mu. So we're, oh, let's see here, change this. Find using table C T star is called a critical value. So to build our confidence interval for this sample, right, let's construct the 90% confidence interval for the dissolved oxygen sample. We have everything that we need, right? Because we have X bar, we have S, and we have N. We can find T star, right? The same way that we would have found Z star, we just need to find our degrees of freedom, right? So using table C, with degrees of freedom equal to n minus 1, which is 15 minus 1, which is 14. And a confidence level of 90%, because we want to build the 90% confidence interval. Do you mind if I sneak this? Yeah. And then tell mine out. With. Let's see if I can clean that up. Maybe. Okay. So now, right, instead of going all the way down to our Z star line, you're just going to stop at the 14 degrees of freedom line. And that's how you're going to find your T star. So now 90% confidence level, so you can't see it, but you'll have a table in front of you, right? So 90 degrees or 90% confidence level, 14 degrees of freedom, we find T star is 1.761. So make sure that's what you're finding. Bless you. Okay. So now we can go ahead and calculate our confidence interval. So we've got x bar plus minus t star times s over root n. X bar was 4.771 plus minus. The plus minus gives us a lower and an upper bound, right? Because we want an interval. T star, which is 1.761, times S, which was 0.9396, I think, said. Yeah. Divided by the square root of 15, right? N is still 15, our degrees of freedom is 14. So now, I'll do 15, the square root of 15, and then 1 over that times 0.9396. I'm just going to show this middle step, because this is where things go wrong, the 0.9396 divided by the square root of 15, just so you can make sure that you're doing it right on your calculator. I get 0.242603677. Oh, really? 15 square rooted. So that's the square root of 15, right? And then I get 1 over that times. Yeah, what if you do 0.9396 divided by 15 square rooted equals, depending on what calculator you have. Oh, do square root of 15. I'm ready to lock this in. So if you're not getting this answer, yeah, good. I know, yeah, you'll have to get to know your calculator a little bit better, right? Or maybe your best buds already, who knows? No. So now I can multiply this 0.242 by 1.761, and so I get plus minus 0.4272250075. You'll want to figure out what store function your calculator has. Unless it's super, super basic, it usually has some sort of memory, right? Where you can store all these decimal places. So on mine, I just hit store and then whatever button I want to store it in. So 1, let's say. And then to recall it, I hit RCL, so recall 1. But we don't all have the same calculator. So if you want me to check yours out, we can do that. But you want to try to keep all your decimal places. We are talking about the aquatic life being at risk after all. We don't want to be messing around. Okay. How we write this answer, 4.771 plus minus 0.42722, whatever, right? You're gonna find your lower bound first. So in round brackets, and that's important, round brackets, you do your lower bound, so 4.771 minus 0.427, whatever, okay, separated by a comma, right, up to, and then 4.771 plus 0.427, okay, and then close it with a round bracket. Okay. So how you report this interval is important. Okay. So I get 4.771 minus that guy, I get 4, bless you, 4.343774925 up to 4.771 plus recall 1, 5.198225075.
That's lower bound, upper bound.
That's right. So here, right, you write round brackets, lower bound, comma, upper bound, end bracket. Ideally, but it's only, so it's, you only show this step to me because in case you did it wrong, right? Maybe you did 1.762 or whatever, right? Then I can go back and give you part marks at least. So the less work you show, the less marks I can give you if you did something wrong along the way. But if you're very confident, then yeah, you could go straight from here to here. So what does this confidence interval mean, right? And when I'm interpreting it, I'm going to round to 2 or 3 decimal places. Okay. So for our interpretation, we can round to 2 or 3 decimal places. Usually the logic is however many decimal places I gave you, you return to me, right? So match the number of decimal places in the question or at least 2 decimal places. Okay. So in the question, right, I gave you 4.771, that's 3 decimal places and 0.9396. All right, so I'm gonna go to 3 decimal places to match that one with the least decimal places, right? But a minimum of 2 decimal places is what I wanna see. Okay. So then rounded, we have 4.344 to 5.198. So then, what we're saying, right, if we scroll back up to this idea, is that we're 90% confident, right, that this interval captures the population mean, right, of the dissolved oxygen in the streams. Okay. So we have a standard blurb for interpreting our confidence interval as well, right? And so I'll write it out for this question and then do the generic one kind of backwards this time. Okay. But what we say is we are 90% confident, confident the interval from 4.344 to 5.198 captures the population mean dissolved oxygen level in the stream. keep in mind, right, the whole idea is that we don't know what the population mean is, right? So with hypothesis testing and confidence intervals, we're constantly trying to figure out what it might be, right, the population mean, right, trying to pinpoint what it's going to be. So if we're saying that we're 90% confident that the population mean is captured somewhere in there, right, a mean of 5 is in here, right? So what we're saying is that we're 90% confident that, yeah, a mean of 5 is in this interval, right? Going back to our original hypothesis. So since 5, or since H naught is that mu equals 5 is in this interval, we do not have enough evidence to reject H naught. We do not have enough evidence to reject H naught. Because there's nothing about this interval that says, oh yeah, the mean is less than 5, right? Because a mean of 5 is in this interval. So this 90% confidence interval, right? A 90% confidence interval corresponds to a one-sided alpha level of 0.05, right? So if you have a one-sided test of 0.05 or a two-sided alpha level, right? Because two sides, you'd have to take into account the area in both sides of 0.1. So a 90% confidence interval corresponds to a one-sided sided alpha level of 0.05 and a two-sided alpha level of 0.10, right? So if you have a one-sided test, which we do, right, and I tell you to use an alpha level of 0.05, right, that means you have 0.05 in one of the tails, but that has to be duplicated in the other tail, right? So a confidence interval that would test the same thing as what you're trying to test with the hypothesis test would be a 90% confidence interval. Do you have that table? I can sneak again. Sure. Thank you. So if you have a look, right, at your table, if you go to 90% confidence level, it'll just scroll and then scroll down to the one or the two-sided p's, right? It'll tell you that, okay, a 90% confidence level corresponds to a one-sided alpha level of 0.05 and a two-sided alpha level of 0.1. Okay. So I think, I can't remember if it's on the assignment, isn't it? It is. Part B for question 2, use a confidence interval equivalent to an alpha level of 0.05 for the house prices today. So then I get you to sit down and figure out, okay, did I have a one-sided or a two-sided test? And then what interval am I going to make? A little bit of a thinker. Let's do our general, yeah. For the confidence intervals. So we don't, yeah, so T's don't come into play in confidence intervals at all, which is kind of nice, right? people tend to prefer confidence intervals because as far as the work goes, right, you have to show your work finding your t-star and then calculate your interval, and then we just interpret our interval, and then we're done, right? So let's do a generic confidence interval interpretation. You're going to say we are blank percent confident the interval from blank to blank. Right here, you're careful to write your lower to the upper. Right, if I told you the interval from 5 to 4, that doesn't really make sense, right? An interval goes from the lower to the upper, right? So the interval from 4 to 5, for example. And I will take marks off if you've got your lower and your upper switched around, okay? Just because those intervals don't exist, right? You have to go from lower to upper. So we're blank percent confident that the interval from the lower to the upper captures the population mean and then whatever the question is, right? The population mean dissolved oxygen level, for example. So from the question. And then we'll say since H naught mu equals some value, right? Is or is not, doing both in one sentence. How did I say it here? In this interval, we have or do not have enough evidence to reject H naught. Oops. Right. So if mu is in that interval, then I've got these switched around. That is not very helpful, is it? Yikes. So if mu is in the interval, we do not, have, and if it's not in the interval, then we do have. Yikes. It's because I'm so hung up on p-values. It's kind of the backwards of the p-value, right? If your hypothesized mu is in the interval, then you don't have enough evidence to reject the null hypothesis. If it's outside the interval, right, then your sample is saying, hey, I think my mean's over here somewhere, right? And your hypothesized mean is outside of that, then you can reject the null hypothesis. Okay. So I've got another example here. Oops, not that one, this one. In case you're copying these out, don't really have to, but I put the part in italics that you don't actually need. It's just a little explanation of what's going on. So you don't need that italicized stuff in the beginning, but you will need the stuff after. So business bankruptcies in Canada are monitored by the Office of the Superintendent of Bankruptcy Canada. Ugh. Included in each report are the assets and liabilities the company declared at the time of the bankruptcy filing. So now we're looking at a studies based on a random sample of 75 reports from the current year. Okay, fine. So we have a sample size of 75. The average debt is $92,172 with a standard deviation of $111,538. Okay, so you've got a sample mean and a sample standard deviation and a sample size. Okay. Oh yeah, sorry. Is there evidence that the mean debt is higher than $110,000? Use a 95% confidence interval for the average debt of these companies at the time of filing to test the hypothesis. What alpha level would this correspond to? So first, I'm going to outline what we're given. So we're given that n is 75. X bar is 92,172, and the sample standard deviation is 111,538. If we're going to test the hypothesis, right, we should probably state our null and alternative hypothesis, right, just like we did for formal hypothesis testing. So step one, I'll say state your hypothesis. We're going to have a null hypothesis and an alternative hypothesis. Oh, sorry. There you go. So we've got our sample information, right? That's what we want to compare to 110,000, right? So our hypothesized mean is going to have to be 110,000, right? Just because that's what we want to compare our sample to. So we're going to have mu equals 110,000. And then we want to know if the mean debt is higher than 110,000. Right, so that's what we want to know. So we want to know if mu is actually greater than 110,000. I'm only concerned with one of the extremes, right? So this is a one-sided test. I don't care if it's less than 110. I only care if it's more than 110. Okay. So we want a 95% confidence interval. Okay. So construct confidence interval. So we use the same blurb. So using table C, with degrees of freedom equal to n minus 1, which is 75 minus 1, which is 74, right? If you're trying to find 74, right, it's not on the list. So, right, so you go here and you try to find your 74, right? Tempting to jump out to 80, right? But we can't do that. We have to go down to 60, right? And so because 80 would assume that we have a sample size of 81, so meaning our results would be more accurate than they actually are. So we can't do that. So then if you have to jump down, then you say using degrees of freedom equal to 60. Right, just to show to me that you know, okay, I've reached 74, I couldn't find 74, there's 60 or 80 to choose from. I know I have to choose 60. With a confidence level of 95%, 95% scrolling down to 60 degrees of freedom. Oh, wow, beautiful. And even 2. Nice, thank you. Sound familiar? Right, 68, 95, 99.7 rule. We find T star is 2.000. Nice. So now we have our interval x bar plus minus T star times S over root n. X bar was 92,172. Plus minus T star, which is an even 2, times S, which was 111,538. That's a huge standard deviation, right? Meaning there's lots of variability in our data, right? Over the square root of n, which is 75. So first I'm going to find 111,538 divided by 75 square rooted. I get plus minus 2 times 12,879.2986. 92,172. Times 2. I get plus minus 25,000. I'll ditch that bracket. 25,758.59773. Again, I'm going to store that so I can use it. We are talking money here, right? So you would be safe to just go to 2 decimal places. And maybe I will. Maybe I won't. I won't quite yet. Just to show you all the decimal places. This is more so that you can check your work on your calculator than anything else. 92,172 minus that lower bound puts me at 66,413.40227. 92,172 plus 25,000 is 117,930.5977. Or in terms of money, we can say between 66,413 and 40 pennies to 117,930 and 60 pennies. Step 3, let's call it, is interpret the interval. So use that same standard blurb. We are 95% confident, because we built a 95% confidence interval, right? So we're 95% confident that the interval from 600 or 66,413 and 40 pennies to 117,930 and 60 pennies captures the population mean of whatever we're talking about, right? So this is where I'm going to steal it from here. The population mean debt, let's just say, of these bankruptcies at the time of filing, right? But let's just say, mean debt of these companies at the time of filing. That sounds better. Population mean debt of these companies at the time of filing. We wanted to know if the population mean was less, or sorry, more than, right? Yep, higher than 110,000. 110,000 is in this interval, right? Between 66 and 117, we can find 110 kind of comfortable in there, right? So since H naught mu equal to 110,000 is in this interval, we do not have enough evidence to reject H naught. Therefore, the mean debt of these companies, just rewording the question as an answer again, right? At the time of filing, is not higher than $110,000. And then to just quickly wrap it up, because you need it for the assignment, right? Sort of. If you've got a 95% confidence interval here, right, then you've got 5% split evenly between each of the tails. So this one, you've got 0.025, and this tail, you've got 0.025. A 95% confidence interval corresponds to a one-sided alpha level of 0.025. And a two-sided alpha level, why not show off? and a two-sided alpha level of 0.05. Right. So we were doing a one-sided test, right? Is mu greater than 110? So we would use an alpha level of 0.025, and vice versa. Okay. So make sure you grab assignment 4 in the practice test. Do the practice test, remember, for next day for those completion marks. You want to get those. If you still have stuff to pick up from me that's marked, you can do that too. Otherwise, I'll see you on Wednesday. Thanks.